Alright guys, this will be your first of 3 videos. This one will be all about carbohydrates. I just kind of wanted to give you all your need to know information on carbs. Kind of just a quick crash course, get to the point, learn what you need to learn, review what you need to review, and then move on. So anyway, I'm going to go over some carbohydrates. First off, let's talk about the structure. We have carbon, we have hydrogen, and we have oxygen. Those are our 3 elements in carbohydrates. If you remember, when we were in class, we went over the formula, which was CX, H2X, OX. And we did some examples because that's kind of vague and too much algebra for our liking. So in other words, if we have 6 carbons, we're going to have double that amount of hydrogen, so it's going to be H12. And we're going to have the same amount of oxygen as we are going to have carbon. So it's going to be O6. Another example, if it was, I don't know, like C12, it'd be H24 because it's double that amount. And then once again, O12. So that's our structure. That's your need to know information on the structure of carbohydrates. And that's pretty much it. We already talked about our function of carbohydrates. You guys did pretty well with that, which was short-term energy. And then we went over the monomer and the polymer. So our monomer was anything for carbohydrates has the root word saccharide in it, or saccharose. Our monomer was a monosaccharide. Mono meaning one, saccharide meaning sugar. So this literally means one sugar. Okay? We went over 3 different examples of our monosaccharides, and our examples we went over were glucose, we went over fructose, and our last one was galactose. We talked about that each one of these has the exact same chemical formula, which is C6H12O6. In other words, the same as this guy here. But it's weird because why would you call them something different if they're all the same? What we called there, the vocabulary word, was an isomer. An isomer is simply a molecule, or in this instance, a carbohydrate, that they're all going to have the same chemical formula, but the difference is the way these elements and these atoms are put together. So the way they're put together is completely different, which is why they have 3 different names. And that was our monomer. All right. And then lastly, we went over the polymers. Okay. We had our disaccharide, which was 2 monosaccharides bonded together. So this literally means 2 sugars. Okay, that was our first one. And then our second one was a polysaccharide. Okay. Poly means many, and once again, saccharide means sugar. So if you notice, with all these carbs, the thing that we're seeing common is saccharide, saccharide, saccharide. Anytime you guys see saccharide, it's automatically a carbohydrate, right? So now to kind of apply our condensation and dehydration reactions to all this stuff. Okay. Let's say we have 2 monosaccharides, and I'm just going to represent them by circles. We have 2 monosaccharides. So here's a mono. I'm just going to write MONOS. So we know it's a monosaccharide. And we're going to bond them together. If we bond them together, there's our bond in between them, we now have 2 monosaccharides bonded together. We call this a disaccharide. Okay. Now, here is the important part to relate this to condensation and hydrolysis reactions. If we are combining these together, we are building up. So we're building up this molecule. Right? Making it bigger. If we are building it up, it's automatically going to be a condensation or dehydration reaction. Same word, or I'm sorry, different word, same meaning. All right. So that's the one thing you have to know, is that when we build things up, it's condensation and dehydration. And when this bond comes together, out of it, we also get one water molecule. Okay? So whenever that bond is formed, we get one water molecule out of it. All right? So that is our condensation and dehydration reaction for carbohydrates. Let's go the opposite way. So let's say we got a really, really, really big string of carbohydrates. Okay? It would be bigger than that in real life, but I'm simplifying. And we are going to pluck one of those monosaccharides off of our polysaccharide. So we have 1, 2, 3, 4, 5, 6 monosaccharides bonded together. That's why we call it a polysaccharide. And let's pluck one off. So we will have 5 plus 1. Okay? So if we look here, we broke one bond. And we broke this bond right here. Okay? This, since we're breaking it down from here to here, this is a hydrolysis reaction. Okay? Reason being, we're taking a very big polysaccharide. Like I said, in reality, it would be bigger. And we're breaking it down into something smaller. Yes, we still do have a polysaccharide here, but we are taking off our one monosaccharide. Okay? Now, the one thing you need in order for this to happen is water has to come in and go to that area where the bond is. If there's no water available, the bond will not break. So on the reactant side over here, we need one water molecule as well. All right? And that's pretty much for carbohydrates, guys. Big points to take away, I would say, would be know your monomer, know your polymers, know your condensation and dehydration reactions for building up, know your hydrolysis reaction for breaking it down, know where water is needed, and then know your structure of the C6H12O6, that type of thing. And lastly, just know that whenever you are using a carbohydrate, it's going to be for short-term energy. I think this is all you need, guys. This is like the needs-to-know material for carbohydrates, especially too with the monosaccharides. Make sure you know the glucose, the fructose, the galactose, they're all the same, but they are isomers because the way they're put together is a little bit different. All right, hopefully this helped, guys.